السلام عليكم ورحمة الله تعالى وبركاته. في هذه المحاضرة سوف نشرح Ordinary Differential Equations. Differential Equations should be linear، يعني معادلة خطية أو non-linear. تعال نشوف ماذا يقصد بكلمة linear Differential Equations. فالصيغة العامة بتاعت linear differential equations general formula, it can be written like this: dy sorry زي ما قلنا a general formula of the ordinary differential equations can be written as this, like this. So dy over dx plus px, function of, this is a function of x, y equal q of x. Whenever you find any differential equations in this form, so it is linear. So let us take some examples of linear and non-linear. Here, for example, dy over dx plus 3xy equal to x, for example, this is linear because y here y raised to the power 1, and here y to raise to the power 1, the same form. So this is linear. Okay. Again, dy over dx plus 1 over xy equal e to the power x. Also, y here the same as y in the general form. Y raised to 1. Okay. So this is linear also. This is linear. Okay. Another example of linear. For example, dy over dx minus 2y equal e to the 3x, for example. This is also linear because y is raised to the power 1, linear. Okay? Okay. Now let us take examples of non-linear. Okay? For example, if you dy over dx plus xy squared equal to x, this is not linear because here y is raised to the power 2, and in the general form y is raised to the power 1. This is not linear. This is not linear. Okay, this one. Okay, again, let us take an examples of nonlinear. So if we have dy over dx plus x root y, also this is not linear, x squared. This is not linear because y here is raised to the power half. Because root y equal y raised to the power half. This is also non-linear. Okay? And before we starting our lectures, I would like to remind you with some facts of differentiation. Okay? Okay. If you have two functions, let us have two functions, sorry. Let us have to have two functions, f of x. Okay? that means differentiation of f of x equal f dash of x as you know. Another function, say g of x, and differentiation of g of x is g dash x. So differentiation, if you have the differentiation of f of x times or multiplied by g of x. Sorry, let us dismiss. Okay. If we have differentiation of f of x multiplied by g of x, and differentiation will be like this. So you have to differentiate the first function. So this will be f dash of x. This this is g of x as it is, plus this time you have to differentiate this one. So g of d plus, sorry, yeah, because plus f of x g dash of x. Okay, so when you find this form, if you find the derivative of the first function of x, f dash of x multiplied by gx plus g dash of x multiplied by fx, so this is called a differentiation of a product. Okay? Okay. So let us take examples to explain this. Okay. For example, first example, if we have dy over dx, dy over dx plus 2y equal e to the power x. For example, this differential equation, and we try to find the general solution of this differential equations, and we have some of initial conditions. We can write the particular solution for this differential equation. Okay, so the first thing is that you have to put the general formula like this: plus p of x y equal, that means qx. This is a general formula. By comparing the general formula with this particular differential function, so that you can conclude that p of x equal to p of x. This is equal to, and this is very important. Okay, and now we have to find the integrating factor. The integrating factor equal p raised to the power integration of p of x dx. This is the integration factor equal e raised to the power of p of x with respect to x. So here, instead of p of x, we have to put 2. Okay, so integration factor for this differential equation will be equal e integration of 2 respect to x. So integration factor in this case equal e to the power 2x. Okay, this is an integrated factor, e to the power 2x. Okay, because the integration of 2 is 2x, so e to the power 2x in the integrating factor. The second step is to multiply this integrating factor to all terms of the differential equation of original differential. Okay, so we will have e to the power 2x multiplied by dy over dx, okay, plus e to the power 2x multiplied by h by 2y, okay, equal e to the power, yes, e to the power 2x, to the power 2x multiplied by e to the power x. Okay? Right. Now, so if you differentiate this function, if you differentiate this function, differentiate of e to the power 2x, it will be equal to e to the power 2x. So here, 2 multiplied by e to the power x, so the differentiation of this should be like this. Okay? And differentiation of y equal dy over dx. So these two terms is a product of two functions. These two terms is a product of two functions. So we can substitute it by saying that this two terms is a differentiation of two functions. The first function is y, and the second function is e to the power 2x. Okay? Equal. This will be equal e to 3x. Okay? So we have to integrate both sides. So you will get integrating of just remove this differentiation. So y times 2x equal differentiation of this equal 1 over 3 e to the power 3x. Okay? Now, if we divide both sides, divide both sides by e to the power 2x, here also with 2x. So this will be cancelled with this. So that y equal 1 over 3. E to the power 2x, 3x here, divided by e to the power x, that means e to the power x. Plus c here. Plus c. Sorry. No, we have to repeat this again. Okay, if we differentiate this, we'll get y e 2x. If we differentiate this, that means equal 1 over 3 e to the power 3x plus c. This is a integration constant. So in this case, then we have to divide each term of this equation by e to the power 2x, here also e to the power 2x. So finally this will be cancelled with this. That means y equal, so here 1 over 3 one of the e to the power 3x, so you divide it by e to the power 2x, that means e to the power x plus c multiplied by e to minus 2x. Okay? And this is a general solution. This is the general solution of the given differential equation. So if we have initial conditions, that means if we have the values of y and x, easily we can calculate the value of c. Okay? So let us take another example. Okay. If you have dy over 2x plus xy equal x squared. Okay? In this case, p of x equal x. Okay? P of x equal x. So the integrating factor in this case equal e raised to the power integration of x dx. So the integrating factor will be equal e to the power 2 half x squared. And this is integrating factor. Okay? This is integrating factor. The second step is we have to multiply all these terms by this one. So here will be equal e half x squared multiplied by dy over dx plus here e to the power x squared divided by x y equal x squared. Sorry, x squared multiplied by e to the power half x squared. Okay? So, again, these two terms is a product of two functions. Okay? So this can be written like this. Differentiation of the first function is y, and the second function is e to half x squared equal here x squared times e half x squared. Okay? So if we integrate both sides, integrating both sides, okay? We will get y e half x squared equal. What integration of this? If you differentiate this, you will get this. So here, in this part, consider u equal e equal half x squared. Okay? So then So if you differentiate this, differentiation of this group, so okay, differentiation of e to the power half x squared. It will be equal, differentiation of this equal x. Okay. Differentiation of this x equal half x squared. Okay, and differentiation of this. So if we differentiate this, will be equal so I think this integration should be solved by integration of parts. So let us escape this, because an integration of two parts is, it will take time. It's not difficult. It will take time and I would like the video to be very short, so as to be as uploaded as quickly as possible. Okay. So let us skip this example and write some example. Okay. Now, dy over dx equal, sorry, not equal, plus 1 over x y equal to. So in this case, p of x equal 1 over x. Okay, so the integration factor for this function, for this differential equation functions, so equal e raised to the power 1 over x, because p of x dx. Okay, so the integration factor will be e. The integration of 1 over x equal ln of x. Okay, so the integration factor equal e to the power ln of x. And we know that if e raised to the power ln of x, that means n of e equal x. E, so the integrating factor in this case equal x, because e to the power ln of x equal x. That is, okay, so the integrating factor is x. So in this case, then the second step is to multiply this integrating factor by all terms of the original differential equation. So we will get x dy over dx plus x times 1 of x y, then 2 should be 2x. Okay, so let's cancel with this. So the final equation is like this. X, okay, x dy over dx plus y equal to x. So I think these two terms is a product of two functions. The first function is x. So if we differentiate x, differentiation of x is equal 1. So you can write 1, or Okay, and the second function is y because differentiation of y equal dy over dx. So this term is a differentiation. This is the differentiation of products. The first function is x, and the second function is y. يبقى dxy equal here differentiation of this to x. Okay, differentiation. Okay, so okay, differentiation of this is equal xy. This differentiation of this to x equal x squared plus c. Okay, now divide all terms divided by x. So you will get, okay, here, this will be cancelled with this, and this will be with the square. Okay, so the final solution is, the final answer is y equal x plus c over x. So, or y equal x plus c x minus 1. So this is a general solution of this. Okay? Okay. Now let us do some examples. Okay. If we have x dy over dx plus x plus 1 y equal to, and so this function is no longer in the form of the linear differential equations, because here, because dy over dx multiplied by x. So to make it a linear differential equations is in the form of, so we have to divide this term by x. All terms should be divided by x. If you divide by x here, if you divide by x here, and if you divide by x here, okay, you will get that. You will get an dy over dx plus x plus 1 over x, okay, y equal to divided by x. So this is a general linear differential equations. So, okay, in this case, p of x here, p of x in this case equal x plus 1 over x. So this can be written like this: 1 plus 1 over x. If you divide 1, if you add 1 to the 1 over x, you will get this. If you are not sure, I can show you. So, okay, 1 over x. So this is here the minimum multiple is x. So here, 1 x divided by 1 equal x. X multiplied by 1, that means x plus x divided by x is equal 1, 1, 1, equal 1. So, okay. So this can be written like this, in this form, okay? So in this case, sorry. we have tried to say that p of x equal, p of x equal 1 minus 1 over x. Okay, so the differential equation can be written as follows: dy over dx plus 1 minus 1 over x y. Okay, 2 over x. Okay, so in this case, p of x, in this case, so we said p of x equal 1 over. So the integrating factor, integrating factor, as we said, is equal e to the power p of x with respect to x, right? So since p of x equal 1 plus, okay, so the integrating factor in this case equal e raised, let us do it more space here. Integrating factor be equal e raised to the power 1 plus 1 over x dx. Okay, so integrating factor in this case will be integration of 1 is x, and the integration of 1 over x, it will be nx. Okay, and this will be equal e to the power x multiplied by e to the power nx. And we know that e to the power n of x should be replaced by x. So the integrating factor, e to the power x, so this will be expressed as x. So the integrating factor is x. So just a minute. The integrating factor in this case, in this example, integrating factor equal x e to the power x. This is integrating factor. Okay, so we have to multiply this integrating factor with the term to the all terms of the differential equations. So in this case, we will have x e to the power x multiplied by dy over dx plus x e to the power x multiplied by 1 plus 1 over x. Okay, y here equal 2 to the power x is multiplied by x e to the power x. So this will be cancelled with this. Okay, that's that step. So x e to the power x dy over dx equal plus this time this equal x e to the power x, and this time this equal plus ex. Okay, this is y, and this will be equal to e to the power x. Okay, so what is the differentiation of this function? I think that the differentiation of this function is this one. So I will do it for you. If you are not satisfied, I will do it for you. So differentiation of x e to the power x, this also is a multiple, is a product of two functions. The first function is x, okay, x here, and the differentiation of e to the power x is equal to the power x plus differentiation of x equal 1 طبعا 1 times e to the power x. So I think they are the same. So this is the differentiation of this one. So in this case also and these two terms, the underlying terms, construct the differentiation of the combination of two functions. That means the first function is x to the power e to the power x, and the other function is y, equal the 2 to the e to the power x. Okay, if we differentiate this, you will get here x e to the power x times y equal to 2 to the power e to the power x plus c. Okay, so in this the second step, or divide x e to the power x. Also here divide x by e to the power x, and here also divided by x e to the power x. So this will be cancelled with this, and you will end with y equal that equal, not plus. Equal to the power x, okay, plus c divided by x e to the power x. So y equal to x minus 1 plus c x minus 1 e to minus x, okay? So this is a general solution for these differential equations. Okay. Let us use this example. D squared dy over dt plus 2d y equal cosine t. In this example, you have to think first. You have to look. You have to look to think carefully of these functions. Ask yourself, what is the differentiation of this function? Differentiation of t squared is 2t, and the differentiation of y is dy over dt. So this is ready. You don't need to making integration factor or something like this. Okay? So this can be, so here this is a differentiation of both 2 products, a squared and this is y. Okay, this equal cosine t. Integration of both sides equal t squared y equal integration of cosine equals sine t plus h plus c. In this case, you have to divide all terms by t squared. So you will get finally that means y, because this cancel with this equal sine t divided by t squared, and here plus c t plus c t minus 2. So this is a general solution for this. Okay. Now, so far we end with this example, and next time we discuss second. This is the first order. In the next lecture, we discuss the second order of the differential equations. Okay. Thank you very much.